Hello students, I welcome you all in the quick solutions of All India Akash Test Series Medical 2019. And I'm here with the test number 2 code ENF, and we will be dealing here chemistry part of this paper. Let us begin with the very first question. The question number 46 is here. Average molar kinetic energy of ammonia gas is. In this question, we have different options given here, and we should always know that whenever we talk about the kinetic energy, that is directly proportional to the temperature of the system. And when we talk about this average molar kinetic energy of a particular gas, that's ammonia, that's given here. And for this is average molar kinetic energy, that is equal to 3/2 RT. This is the formula that we use to calculate this average molar kinetic energy, and that is why the correct answer for this particular question is option 3. I hope this question is clear to you. Let me mark here the correct answer. Now it's a turn for question number 47. Question number 47 says, density of ideal gas of molecular mass 32 U at 1.2 atmospheric pressure and 327 degrees Celsius is. We have different options which are given here. And if we are talking about the ideal gas, in this case, the formula to calculate the density is P is equals to dRT upon M. Using this formula, you can easily calculate the density for ideal gas, and that density would be equal to Pm by RT, and that will be calculated by placing the values. We know that the pressure is 1.2 atmosphere. Further, if we talk about the molecular mass is given, that is 32 U, so molar mass is 32 gram per mole, and that's divided by RT. What's the value of RT would be here? That would be 0.0821 liter atmosphere per Kelvin mole. That you'll take here. And then the next thing is temperature. What's the temperature here? That is 327 degrees Celsius. And if you want to calculate this in Kelvin, this would be 327 plus 273. It would be 600 Kelvin. This is basically the temperature of this case, and that I'll multiply here 600 Kelvin. And now if you solve this, you will find out that the value is approximately 0.779 gram per liter. And if it is the value, we can easily choose the correct answer, that is approximately 0.78 gram per liter. And it's given in option 2, 0.78 gram per liter. The answer is option 2. Now after this, it's a turn for the next question. Now here is question number 48. For which reaction delta H is greater than delta U? In this case, one thing we should notice that delta H is change in enthalpy, that's given in the question, and delta U is change in internal energy. We have different reactions, those are given, and one thing we should always know that whenever we talk about delta H value, that is equal to delta U plus delta NGRT. This is the formula, and if you look at this given formula, you will identify that whenever this delta NG value is more than 0, then in that case only the value of this delta H greater than delta U. So this value of delta H is greater than delta U if this condition is fulfilled. And now if you look at the given chemical equations, you will identify that in the first equation, iron is combining with carbon monoxide to give you iron carbonyl, and in this particular case the value of N2 minus N1 or this delta Ng is minus 5, because in this case the value of N1 is 5 while N2 is 0. That is why the value of this delta Ng for this particular case is minus 5. Now carbon in the form of graphite combining with oxygen to form CO2. In this particular case, if you look here, that the value of this delta Ng is 0. In next case, if you look at this delta Ng value is also 0. Further, we have the fourth equation in which calcium carbonate is decomposed to form calcium oxide and carbon dioxide, and in this case the value of this delta Ng is 1, and if it is 1 it means it is more than 0, and that's why the correct answer for this particular question, the case for which delta H value is more than delta U, that is the case is equation of decomposition of calcium carbonate, and that's why I can write here the correct answer, that is option 4. I hope this question is clear to you. Now let's move on to the next question. Now here is question number 49. The correct thermodynamic conditions for a non-spontaneous reaction at all temperatures is, and here are several conditions which are given, and one thing we should always remember that whenever we talk about non-spontaneous reaction, it means the delta G value should be positive, because we know that in case of spontaneous reaction delta G value is always negative. So here we have to find out the case in which this delta G value becomes positive, and we know that this delta G is equal to delta H minus T delta S. So we have to find out that condition for which this delta G value is positive at all temperatures. So we know that to make this delta G value negative or less than 0, always delta H is less than 0 while this delta S is more than 0. It means positive. This is the condition for spontaneous process. But in this case, we are not talking about the spontaneous process, we are talking about the non-spontaneous process. It means we need this delta G value as positive, and in that case, we have to take this delta H value that should be more than 0 or positive, and this delta S value should be less than 0 or negative. And if this is the condition, then definitely for this condition, delta G value would come out to be positive or more than 0. And in that case, definitely the process is non-spontaneous at all temperatures. And this condition is given in option 3. That's why I'll mark here the correct answer for this question. That's option 3. Now let's move on to the next question. Question number 50. Universe is an example of. If we talk about universe, that is the case of an isolated system. So simply universe is an example of isolated system, because in this case there is no exchange of mass and energy between the system, that's the universe, and surroundings. That's why which option is correct? You can easily choose that correct option is option 3. Now it's a turn for question number 51.